1 mole of an ideal gas is taken from state A to state B by 3 different processes ACB, ADB and AEB as shown in the PV diagram. Which of the following statements are true about the heat absorbed by the gas? So the heat absorbed by the gas is given by delta Q is equal to the change in internal energy of the gas plus the work done by the gas on the surroundings. Therefore, if there is a work output from the gas, that is considered positive in this case. Now let us look at process ACB. When the gas goes from A to C, the volume of the gas reduces, which means work is done on the gas, or the gas does negative work on the surroundings. But between C to B, the gas is expanding. Therefore, the gas is doing work on the surroundings. So, between C to B, this is the amount of work that is done by the gas. And we can see that it's a net positive work done by the gas on the surroundings. The ability to do this work must come from the heat input because the internal energy is the same compared to all other cases. Therefore, in case 1, delta Q is greater than delta U. Now let's look at case 2. In case 2, it is a simple isochoric process, that is, a process that happens at a constant volume. In such a process, there is no work done since there is no displacement. And therefore, heat added to the gas is exactly equal to the change in internal energy of the gas. Now in case 3, we have between A to E, there is some positive work done by the gas on the surroundings. But between E to B, the surroundings do some work on the gas, or W is negative since the gas does negative work on the surrounding. That means for case 3, delta Q is less than delta U since the work done by the surroundings on the gas would contribute to the internal energy rise. Therefore, delta Q does not have to be such a high value. Now with these 3 statements in mind, what can be said about options A, B, C, D? Option A is wrong, option B is also wrong, option C is also wrong, but option D is correct, and hence option D is the correct answer.